Hello and welcome to PH Maths. Today's explainer is surds, roots that don't simplify to nice integers. Root 2, root 3, root 5. They look intimidating, but the rules are surprisingly clean. By the end of this, you'll know how to simplify any surd, how to rationalise a denominator, and the one trap that catches half of students. A surd is a root that gives an irrational answer. Root 2, root 3, root 5, yes. Root 4 equals 2. So no, that's not a surd because the answer is rational. Surds are the leftover roots that won't reduce to a tidy number, and the skill is keeping them in exact form throughout your working, symbolic and never decimalised. Here's the key insight. To simplify a surd like root 50, find the largest square factor. 50 equals 25 times 2. And 25 is a perfect square. So root 50 equals root 25 times root 2, which equals 5 root 2. To rationalise a denominator like 1 over root 3, multiply the top and bottom by root 3. Gives you root 3 over 3. Clean. Classic mistake. Root a plus root b is not equal to root of a plus b. Try it on numbers. Root 4 plus root 9 equals 2 plus 3 equals 5. But root 13 is about 3.6, completely different. You can't combine surds across addition. Multiplication and division, yes. Addition, subtraction, no. Quick example. Root 50 equals root of 25 times 2, which is 5 root 2. 1 over root 2 multiply top and bottom by root 2 gives root 2 over 2, and root 5 all squared equals 5. Squaring removes the surd, because squaring undoes the square root. 3 essential moves.